Good evening, students. So, in the previous video, we have seen condensation structures, bond length structures. That means various ways to write the structures of organic compounds. So, in the textbook, all these examples we have seen. All these examples we have seen yesterday. That means in the previous video. And today, we will see the way to write uh, for cyclic compounds. For cyclic compounds, how to write the structures. That means here, if you see these structures, in the cyclic compounds, the bond line formulas may be given as follows. And here it is given cyclopropane. Cyclopropane, that means CH2, 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 this one. So here, if we expand this structure, then it will be like this. See, H, H, here C, H, H, and here H, H. This is the expanded structure. That means complete structural formula. Complete structural formula. And bond length structure, if we write for this one, is just like a triangle. Just like a triangle. So this corner is this CH2, this corner is this CH2, this corner is this CH2. So this is bond length formula. This is complete structural formula. This is commonly dash structure, dash structure. So like that, it is given pentane also. This is simply in bond length formula we describe pentane like this. This means that here CH2, 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 everywhere, every corner you are seeing it is a CH2, 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 CH2. So it is like this. And one more example given is chlorocyclohexane. This is cyclopentane. 5 carbons are there. 1, 2, 3, 4, 5. 5 carbons are there. So it is cyclic structure. So it is cyclopentane. Like that, cyclohexane is like this. Here chloro is there. So this means CH2, CH2, CH. Here chlorine is there. This is CH2, 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 CH2. So all the CH2 and here CH only, because one extra chlorine bond is heteroatom. So here carbons and hydrogens we do not have to show. Only heteroatoms we have to show. Heteroatoms we need to show. For example, if we want to write this one, you can see no carbons and no hydrogens are seen. Only heteroatom bromine is seen. Bromine is having 3 lone pairs of electrons, so bromine is seen here. And the same way, if we want to write for nitrogen, this is propylamine, 1 propylamine. So you can see nitrogen here. And propanol, 1 propanol, like this. Only oxygen. That means heteroatom. Heteroatom means the atom other than carbon and hydrogen. That means oxygen, chlorine, bromine, iodine, fluorine, nitrogen, and sulfur, phosphorus. All these are heteroatoms. That means other than carbon and hydrogen. These must be shown. And carbons and hydrogens we do not have to show. So this is the way to write the condensation structure, bond line structure, dashed structure, and total complete structural formula. This is total complete structural formula. Okay. Now some problem is given here. We will see how to do that formula, how to do that problem. So here expand each of the following condensed formulas into their complete structural formula. Complete structural formula he is asking, and he has given is CH3, CH2, CO, CH2, CH3. This this formula he has given. So he is asking us to write the total complete structural formula. So here carbon is there. Carbon, it is having three hydrogen, 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 and that carbon is having bond to carbon, and that carbon is having two hydrogens like this, hydrogen, hydrogen, and this carbon is having carbon, and that is having oxygen, and here H, H, this CH2, and this CH3, H, H, H. This is the complete structural formula for the given question, for the A bit of the problem. So another problem, another bit what they have given is CH3, CH double bond, CH, CH2 three times he has given, CH2 three times, and CH3. So here carbon is having three hydrogens, this carbon is having three hydrogens, and this carbon is bonded to this carbon, and that is having one hydrogen, and this carbon is having double bond here, two bonds, and carbon, and that is bonded to hydrogen. We can write above or below. So if we write above, it is cis, if we write below, it is trans. That we will discuss when we come to cis trans isomerism, that means geometrical isomerism. So here this carbon is bonded to two CH2 groups, that means C, H, H, this is one CH2 group, and another CH2, CH2, and another three are there, another CH2, and after that CH3 is there, H, H, H. So this is how we have to expand uh, this one. So this CH3, this CH3 is this one, this CH is this one, this CH is this one, and this CH2 thrice, that means from here to here, and this CH3 is this one. Okay, so that is how we have to expand the formula. Okay, and after that one more problem is given here is for each of the following compounds write a condensed formula and also their bond length formula. So here structures are given and asked us to write condensed formula and bond length formula. So here we will write the structure OH, CH2, 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 and here CH is given, and in bracket CH3 is given, CH3, and CH is given, and in bracket again CH3 is given, and after that CH3 is given. This is what they have given the structure, this one. So now this OH is there, condensed formula we will write first, condensed formula. So this OH as it is we will write here like this, and CH2, 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 three CH2s are there. So that CH2 three times we can write, thrice, and after that CH, CH3, CH, CH3. So CH, CH3, CH, CH3 means we can write CH, CH3, and this CH, this CH3, CH3 twice we can write, twice, because this CH3 is also on this carbon, this CH3 is also on this carbon, because this is given in the bracket. So this CH is there, and to this carbon only this CH3 also bonded and this CH3 also bonded. For that reason CH3 twice we can write. Okay, so this is condensed formula. Okay, now bond length formula we can write. Here I have written OH, here CH2. Because this oxygen is heteroatom, we have to write OH. and this is CH2, this one, this is CH2, this one, this is CH2, this one, 3 CH2, 1 2 3, that means 1 2 3, 3 CH2s are there. And then this CH, and this CH3 is available, this CH3 I wrote like this, and again CH is there. After that, one methyl group, another methyl group. So this is how we have to write. So this CH3 is this one, this CH3 is this one, this CH is this one. That's why I wrote on this CH3 is there. That means this CH3 are there. So after that, this CH, and this CH3 is here, and 3 CH2s, methylines, 1 2 3. To that, OH is bonded. So this is bond length formula for the question they asked. Okay, and then this is A bit, this is A bit, and B bit also they asked. So for that B bit, here C triple bond N, that means nitrile group they have given, nitrile group, and then that is bonded to carbon and OH, and another CN is given, triple bond. This is sp hybridized, this is sp hybridized, this is sp3 hybridized carbon. Okay, because this carbon is bonded to three bonds, means a triple bond. This carbon is bonded to triple bond. So this carbon sp hybridized, this carbon is all are single bond. So this is sp3 hybridized carbon. Okay, now we have to write a condensed formula for this one. Condensed formula is, here this carbon and this carbon all are available. So this carbon I will write here first, this carbon, and then hydrogen, and for that this OH I will write here, and this CN two times are there on this carbon, this side two times are there. So CN twice we can write like this. So this carbon is this one, and that OH is there, and these two are, this CN are on this carbon only, so twice we can write. This is condensed formula. This is condensed formula. Now bond length formula, if we need to write, so bond length formula, functional groups we have to write total, and only carbons and hydrogen we do not have to write. So this side, this carbon, here OH is there, this is OH, and this side, this bond, here CN is there, and this carbon also CN is there, like this. This is bond length formula, or even we can further expand this one, like OH, and here C triple bond N, and C triple bond N. Like this we can further expand this one. So this is bond length formula. Either this one or this one, both are correct only. Okay. So this is how we have to write bond length formula. And after that, one more problem they have given is, expand each of the following bond length formulas to show all the atoms including carbon and hydrogen. So here these four are given here, and these four molecules are four compounds. We need to expand them, totally. That means complete structural formulae we have to write. So the first one is isopropyl cyclohexane. The name of the compound is isopropyl cyclohexane. This is isopropyl group, this is cyclohexane group. So for that, how we have to write is, all are CH2, C C C C C C C. So all are C, and all are H H. That means each carbon is having 4 bonds. So this is 4 H H. This is 4 bonds. Here isopropyl group is there. Here C H, and this is methyl C H H H, and this side also this methyl is there, C H H H, like that. So CH3 CH3 CH, this is CH, because three bonds are there, one more hydrogen will be there, CH. Okay, so now here one hydrogen is there, one hydrogen, because it should satisfy the valency 4. So one hydrogen is there, and here hydrogen, two hydrogens on this carbon also, two hydrogens on this carbon also. Like this, every carbon must have four bonds, because no double bond is there, no triple bond is there. It is an alkane, cycloalkane. So every carbon must have four bonds. So like this, this one we have to expand a complete structural formula in this way. And one more example, this one. This is how many carbons? 1, 2, 3, 4, 5, 6, 7, 8. N octane. The name of the compound is N octane. N octane. How we have to do this one is, end carbons are methyl groups. H, 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 methyl group. After that C, H, H, this one. After this one, C, H, H. 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 Well, this one, seventh carbon, H, H. After that, the end carbon is methyl. That means three hydrogens, because it should satisfy four valence, four bonds. So this is methyl group. So in this way, we have to write the structure. And one more compound we have given is this one. Triple bond is given. This is A, this is B, this is C, and here it is there, here OH is there. So now we have to expand this complete structural formula. So this is, here carbon is there, and only three bonds are there, but that means one hydrogen will be there. H, C, triple bond, like this. Here carbon is one hydrogen will be there, and this is also on carbon, this carbon, and this side bond is there, that means three bonds. This is fourth bond, so this carbon will not be having any hydrogens, no hydrogens on this carbon. So this is having bond here, that means this is carbon, hydrogen, hydrogen, because it should shadow four bonds. So after that, this is carbon, this is oxygen, this is hydrogen, and here three bonds are there, that means one hydrogen will be there. And here this is the methyl group, like this. So this is how we have to write that complete structural formula. This CH, this C, CH2, this is CH, OH, this is CH3, CH3. So like that we have to expand that one. And one more D they have given is like this zigzag compound they have given. So obviously here this carbon, here this carbon, three bonds are there on this carbon, three bonds are there. That means one hydrogen will be there, one hydrogen will be there. All are remaining, all are methyl groups, because end chain end carbons, those are so methyl groups. So this is CH3, CH3, CH, and here carbon is there, hydrogen is there, and this side also H, H, H. This one, this is this one, this one is this one, this is this one, and here bond is there, and here also only three bonds are there. Carbon, H, H, H. This side also H, H, H. So this carbon four bonds are there, this carbon four bonds are there, but this carbon is only having three bonds. That means it is having one hydrogen here. So like that, above or below, you can put above or below hydrogen. So this is how we need to expand. This carbon is this carbon, this carbon is this carbon, and this carbon is this carbon. Okay. So this is how we have to expand the structures. Okay, and these are the ways to write bond length formulae and condensed formulae. We'll stop here, and tomorrow we'll see another topic. Next video. Thank you.